Okay. So we talked on Friday about, and we did it really quickly, but we talked on Friday about those different angle relationships, and we said there's 4 of them. And you can say something like this. These are what kind of angles? They are, but like what's the angle? Sorry, let me rephrase. What's the angle relationship between x and 116? So these are alternate interior. And we know that alternate interior angles are congruent if these 2 lines are what? Parallel. How do you know that these 2 lines are parallel? Those little red arrows. They never touch, and then they put those 2 little red arrows on there. Okay, they're not always going to be red, but those 2 arrows mean that they're parallel. So because they're parallel, you guys could say in your rewind that x had to be equal to what? Yeah, exactly. X was equal to 116. What if I had put x here? Then what would you have done to find x?
Subtract 180.
Subtract from 180. Why? Because what's the relationship here between these 2 angles? Same side interior. And same side interior is the only one that's different, right? Same side interior adds up to, what's the word we use for that? Supplementary. All the other angle relationships are what? Congruent. If and only if these 2 lines are parallel. Because for instance, if my lines look like this, do those appear to be parallel? No, because they're going to touch at some point. And then if this were my transversal, this would be an alternate interior angle to this. Do these angles look like they're equal? No, because this one looks like it's bigger, it's like obtuse, and this one is acute. So the only time these angle relationships work is if the 2 lines are parallel. What we're going to talk about today is that works backwards too. So if I told you something like this, if I told you that angle F is equal to 110 and angle A is equal to 110, then what do you think you could tell me about lines X and Y? So think back to what we said before in the rewind. Because these lines are parallel, I can say what about these 2 angles? They're congruent. If I tell you the angles are congruent, what could I tell you about the lines? Not that they're congruent. The lines, yeah. The lines can't be congruent because they're just infinite. What do you think I could tell you about the lines? If I know that the angles are congruent, then how could I work backwards to tell you something about the lines? Somebody just said it. Luis? Yes, you can conclude then that lines X and Y must be parallel to each other. Because if they weren't parallel, would these angles be the same? No. So we can now conclude that line X and line Y are parallel. All right? Now, how do we prove that? Or what's like the theorem that we use to prove it? And when we're talking about geometry, we use things called theorems and postulates to prove different things all the time. And so the theorem that you guys used on your rewind was the alternate interior angles theorem, because your angles were alternate interior angles. What we're doing now is we're flipping that. We're doing it backwards. So we would figure out what's the angle relationship here. So what relationship are A and F in? They're corresponding angles. So we would use what's called the converse of the corresponding angles theorem. Converse just means flipped. So it just means backwards. So before, like on Friday or on your rewind, I would give you something like this. And I would say this line is parallel to this line. So if this angle is 85, then what's this angle? And you guys would tell me that x was what? 85 degrees. That's the corresponding angles theorem. Because those are corresponding angles on parallel lines, we can say that they're equal. This is exactly like that, but backwards. Okay? So because the angles are equal, now I can prove that the 2 lines are what? Parallel to each other, exactly. And parallel means that they will never touch. So the only difference is that you slap the word converse in front of it, okay? Because converse just means flipped or backwards, okay? So if I told you something like, if it's Tuesday, then you go to work, the converse would be, if you go to work, then it's Tuesday, okay? So it's just flipping the order. So instead of starting with parallel lines to find angles, now we're starting with angles to find that the lines are parallel. So it's exactly the same thing, we're just proving it backwards, and because it's backwards, we call it converse of, okay? So converse just means like backwards order. All right, that's written right here for you, but again, in fancy terms, okay? So this is basically just saying, given two congruent corresponding angles, and remember, this will be posted, so the YouTube link will be posted and also the notes will be posted. So if you don't get it all written down, it's all on Google Classroom. So given two corresponding angles, the lines are parallel. The same thing would work here if we had like angle B is equal to 70 degrees and angle E is equal to 70 degrees. These are also corresponding, so the same theorem would work here. The same converse of corresponding angles would work here as long as they're in the corresponding angles relationship. And what's corresponding again? That's the one people always forget. I don't know if they just forget the word or the actual like description, but people always remember alternate interior, alternate exterior, but people forget corresponding. How do you recognize corresponding? Okay, good, yes. Okay, so same side, but one's inside, one is outside. Good. Same side of the transversal, but one's inside, one's outside. Good. Pretty much I tell myself if one is inside and one's outside, that's all you really are looking for, because usually they won't give you other ones. Okay. So could we prove these lines are parallel using this theorem? Yes. Why? They're corresponding angles, and the angles are congruent. Okay, so yes, we could say that this line is parallel to this line. What about these? Whoops. What about these? Give me 1 second. All right, what about these two down here? Can I use the corresponding converse of corresponding angles theorem here? No. Why not? These aren't corresponding angles. Yeah. What are they? Alternate interior. And alternate interior angles have to be what? Congruent. Are these congruent? Yes. So do you think those lines are parallel? Yes. But what theorem do you think I would use? I can't use the converse of corresponding angles because they're not corresponding angles, but say that louder. Exactly. Have you ever heard of that before? Then how did you know that? Because you said converse. Yeah, converse means flipped it. So all we're doing is flipping it. So this theorem would be the converse of alternate interior angles. Converse of alternate interior angles. As long as these two angles are congruent, then that means what about these two lines? They must be parallel. And again, parallel is a fancy word for what? Lines that never touch. But they have to be, what kind of lines? They have to be can't have collinear lines because they're, starts with a P, coplanar. They're on the same plane. Okay, so these two lines would be parallel because of the converse of alternate interior angles theorem. So here are your other theorems. We have 4 of them, just like we had 4 before. We have 4 converse ones because every angle relationship we talked about before, the 4 that we talked about before, also has a converse, which just means you flip it. So the corresponding angles alternate interior angles. If the angles are congruent, the lines are parallel. Then we also have the alternate exterior. So these are congruent, therefore the lines are parallel. All right, converse of same side. Again, this is the only one that's a little bit different because same side interior angles do what? Equal 180. So that means these two angles have to equal 180. All right, so now that they do, because what's 150 plus 30? Yep. Then I can say that these two lines are parallel. So you're always proving with a converse, what are you always proving? That the lines are parallel. So you're always proving that the lines are parallel, and you want them to be congruent in every case except for same side interior. So same side interior, how do you recognize same side interior angles? They're both inside the sandwich bread and they're on the same side of the transversal. So they're both inside the parallel lines, but they're on the same side of the transversal. And they need to add up to 180. You can also recognize it because this is what kind of angle? Obtuse, and this one is acute, whereas all our other pairs were the same, right? They were either both acute or both obtuse. So same side interior are the only ones where you might have a difference. Okay, so let's try to use this. What theorem could we use to prove that lines P and Q are parallel? So I want to prove that lines P and Q are parallel here. Can I do it? Yes? Using what theorem? Close. Converse of alternate interior. Okay, do I need this word converse? Yes, because otherwise I would be proving that the angles are congruent, and I already know that, okay? So when you're trying to prove something, what does that mean to prove something? To prove something. Justify it, exactly. So you're trying to come up with a reason that it's true, all right? Because you don't, if you have like, if I told you that prove that Ms. Burton is wearing gray pants today, you wouldn't have to do it, right? Because you can just see I'm wearing gray pants. But if I told you something like, prove that I wore jeans yesterday, you would need some type of reason, right? You would either you'd need like a picture of me from yesterday, or you'd need me to have told you. So if you're proving something, there's some burden that you have to like justify it with a reason. That's what we're doing here. So right here, this is your reason that these lines are parallel. So now we can say that P is parallel to Q. And again, this little symbol right here just means parallel. So P is parallel to Q. Okay, this one says find the value of X that makes M parallel to N. So the first thing you need to decide is what's the angle relationship here? Alternate interior, which means that they have to be congruent if these lines are going to be parallel. So how would I figure out X then? Make them equal each other. Good. So make them equal. So 2X equals 80. All right. Again, what are my two options? I'm either going to make them equal or I'm going to add up to 180. When would I add up to 180? Same side interior. Here, these are alternate interiors, so I make them equal. And then how would I finish this? Yeah, just divide by 2, so X must equal 40. And that's it. Okay, so that's all you're trying to do there. All right, so to sum up, is the word converse important? Yes. Yes. What does it mean? Opposite. So if I told you if it's sunny, then it is hot, what would be the converse? If it's hot, then it's sunny. Okay, that might not be true, but that's what converse means, just flipping the order, right? So all we're doing here is flipping the order because what are we trying to prove? The lines are parallel, not the angles anymore. Okay, good. All right, try these 4. So for number 1 and 2, you're telling me the theorem that you would use. For numbers 3 and 4, you're finding the x's. Okay, so why was number 9 the one that tripped everybody up? They're same side interior. So that's the only one where they don't do what? Equal each other. Instead, they Add up to each other. Good. So they add up to each other. So you did 3x plus 15 plus 75 equals 180. Once everybody got that, everybody got it pretty quickly. Or got the algebra pretty quickly. So that's good. What is the angle relationship in number 4? Corresponding. So you know that P and Q are what? Parallel because of what theorem? Converse of corresponding angles. Does the word converse matter? Yes, the word converse matters because otherwise you would be proving that the angles are congruent, and you already know that because it tells you right here x and x, okay? So you don't want to prove the angles are congruent. You want to prove the lines are parallel. All right, what's going on here in this figure? Don't worry about the question, but what's going on in the figure that's different than what we've looked at before? There's way more numbers. There's 4 lines. Yep. All right. There's 2 sets of lines that appear like they might be what? Parallel. What are the 2 sets that look like they might be parallel? M looks like it might be parallel to N, and P looks like it might be parallel to Q. Do we know that right now? No, we don't have enough information. So in a question like this, 13, 14, and 15 is giving you different pieces of information, and it's asking you to use that information to either prove that they're parallel, which ones are parallel, and if you can't, then to tell you that you can't. Okay, so take a look at number 13. So in number 13, what information do they give you in number 13? They tell you angle 2 is equal to or congruent to angle 11. So we've got angle 2 right here and angle 11 right here. All right, now, which is the transversal that 2 and 11 are on? P. P is the transversal because P is the one that does what? Crosses both of them. It touches both of them. So then which lines would we be trying to prove parallel here? P and Q. Not P and Q. M and N. Okay, because if P is the transversal, then M and N are the ones that would have to be parallel. So which one don't we care about here? Q. They don't touch Q at all, so we don't care about Q in this case. Will we care about it later? Maybe. All right? So I'm only looking up here at M and N. Well, then what's the relationship between M and N? I'm sorry, between these angles on M and N. Are they inside or outside of M and N? Inside. Are they same side or alternate? Alternate. Are they congruent? Yes, it tells you they are. So then what theorem can you use to prove that M is parallel to N? Converse of alternate interior. So we would say M is parallel to N because of the converse of alt int. And you guys can abbreviate this as much as you want as long as you have the converse here. Okay? So you can abbreviate it to your heart's content. If you want to put CAI, that's fine. I just need something that indicates converse. Okay, so here we could prove M and N were parallel. Could we prove P and Q were parallel? No, because these don't touch both P and Q. All right, those don't touch P and Q. So you cannot prove P and Q are parallel. All right, now, number 14. Number 14 is a completely separate problem. So we no longer know anything about 2 and 11. Now all we know is what? 3 and 6 are congruent to each other. So 3 and 6. So now which 2 parallel lines do you think we're going to be talking about? P and Q. Ash, how do you know that?
Because they both, well, 3 lies on P.
3 lies on P and 6 lies on Q. So what's the transversal? M. So which line don't we care about here? N, because they go nowhere near N. So we don't care about N at all. So we're trying to prove that P is parallel to Q. Can we do it? Yes? Why? Alternate interior, and they are congruent. Therefore, we can say P is parallel to Q based on what theorem? Converse of alt int again. So we're using alt int again. And then the last one, what 2 angles do we have? 10 and 15. So 10 and 15. So then which 2 lines will we be talking about being parallel? Q, P and Q. Because 10 is on P and 15 is on Q. And what's the transversal? So which line do we not care about? M. They don't touch M at all. So we're going to try to prove that P and Q are parallel. Can we do it? Yes? Using what theorem? Alt X. Very good. Converse of alt exterior, because we know it has to be the converse because we're proving that the lines are parallel. Then 10 and 15, are they inside or outside of PQ? Outside. Are they on different sides or the same side? Different sides, so that's our alt X. So 15 and 10 are alt X, so we can use the converse of alternate exterior angles theorem. All right, I'm fine with just con alt int, con alt X, as long as I can tell what you mean and as long as you have the converse, okay? You cannot just put converse of alternate. Why? Could be interior or exterior. Yep, so I need enough information. Abbreviate to your heart's content, but I need enough information that I know what you're talking about. All right, what if I gave you this? Could you prove anything there? No, why not? There's not enough information. Is one of them on P? Is one of them on N? No, so you don't have anything that's going to be able to prove M is parallel to N or P is parallel to Q because they're on the same set. So you need them to be in different sets, okay? Would it be helpful either to tell you this one and this one? Well, those are in different sets, that's true. Are they on the same transversal? No, so those aren't on the same transversal. So not only do you need them in different sets, but you also need them to be on the same transversal, okay? Because otherwise, this one's way down here. This one is on the transversal of M. This one's on the transversal of N. So that's not going to tell you enough information, okay? So just be careful because sometimes your answer is going to be neither, all right? Okay, so go ahead and try 3 of these up at your boards. Be careful, read carefully about the angle pairs.